This video is going to be pretty short. It's just going to be about GCF factoring. GCF stands for greatest common factor. Understand, when we use the term factoring, factoring is just another term for division. It's a type of division. That's all we're doing with this, is we are just going to be looking to divide things. More specifically today, when we are talking about GCF factoring, what that means is, when we say greatest common factor, we are going to be given expressions that have multiple terms. What we're going to want to do is look at each term and see what, if anything, we can divide every term by, what the greatest thing is that we can divide every term by. So for example, if we take a look at the expression you can see on the screen, we have 6x plus 12. So what we want to ask ourselves is, first off, how many terms we have. We have two of them. 6x is our first term, 12 is our second term. We want to find a GCF, a greatest common factor. We want to find the greatest number that both 6x and 12 can divide by. So if we just ask what they can both divide by, well, 6x and 12 can both divide by 2. They can both divide by 3. And they can also both divide by 6. The greatest of those numbers would certainly be 6, so that's what we would be looking to divide by here. We are going to divide both these terms by 6. Now if this was an equation that we were solving out for, we would have the other side of the equal sign, and we could divide 6 to the other side, right? We could have equals something over here, and we'd divide that by 6. But we don't have that. We do not have an equation here. We have an expression. There is no other side of the equation. So we can't divide 6 to the other side, which means we can't just divide by 6 and have it disappear. That's not something we can do in math. So instead, we have to keep the 6, but what we'll do is separate it from the two terms by pulling it outside the parentheses, Inside the parentheses, we will write what we would get after doing that division, meaning 6x divided by 6 is just x. 12 divided by 6 is just 2. This would be a factored expression when we're factoring using GCF. We pulled out the GCF of 6 and then wrote what would be left over. Let's take a look at another example. We have 5x to the third minus 7x squared plus 3x. Now if I look at these numbers, 5, -7, and 3 do not have anything in common. So there is no GCF that we can pull out of those. I mean, technically you could divide all of them by 1, I guess, but we don't really need to be pulling out 1s because there's always a 1 as a possibility. What you may notice instead is that while these numbers do not have any common factors, every single one of these terms does have an x with it. We have a 5x to the third, meaning we have x times x times x. We have a -7x squared, meaning we have x times x. And we have a 3x, which is, just x, exactly as it looks. So while it is greatest common factor, and people will get hung up on the greatest part and look for the largest amount, don't miss that C in the middle of the acronym as well, that's common. We can only pull out as much as we have in common with every term, meaning all we can divide by is just a single x, because since there's only one x in our last term of 3x, that's the most I can pull out anywhere. I can only divide by x because this 3x only has one of them. So again, we can't just have that x disappear, we have to pull it outside parentheses. 5x to the third divided by x would give me 5x squared. If you have 3 x's, take one away, we have 2 left. -7x squared divided by x would be -7x. 2 x's, take one away. And 3x divided by x would just be 3, because the x's just cancel out effectively. So this would be another answer by GCF.